thought what I would do today is give you a better feel for what I actually do here in the hood when I'm working with the viruses. What I did before today was I took some GCT cells, actually 6 different plates of them, and I infected them with a virus, actually 4 different viruses that one of my mates here in the lab had worked with over the past few years. And we let those infect the GCT cells for a while, and then we collected the GCT cells and put them into tubes like this. Each of these tubes, and there are 6 of them, represent a different time point. So for example, this tube represents GCT cells that were infected for 24 hours. So from 0 to 72 hours, or 3 days, we let the GCT be infected with the virus. Then we collect them into the tubes. And what I'm going to do now is I'm going to make dilutions of the virus that was in the GCT into these tubes, and use this in turn to infect a new set of cells, and we will use that infection as a measure of the efficiency of the virus in infecting GCT. So in other words, if there's no virus in here, that means the GCT wasn't infected. But if the cells that I use the dilution on today show infection, then that means that the GCT was infected by the virus. I know it's not understandable, but whatever. So what I'm going to do first is I'm going to take my 0 hour. In other words, we just put the virus on and then we took it off right away. It just is like a baseline for us. And I'm going to take this and I'm going to create 3 different dilutions. And the way I do the dilutions, you can think of as if you take, say, a glass of Coke, and it's got a dark color to it. And you take another glass and you put a little bit of water in it, and you take some Coke out and you put it in the other glass with the water, and now the Coke is diluted, right? Okay, and that's basically all I'm doing. So I'm going to create 3 different dilutions of the virus, because the viruses are very small, and if they're present, they're going to be present in the millions and millions and millions, and we want to dilute them down to the point that we can actually count a representative value of how many viruses there might be. So I'm going to take my virus, I give it a good shake, make sure it's all mixed up nicely. This is called a pipette aid, and what we do is we spin it down to determine, to set it for how much of a liquid we want. So I'm drawing basically half of a milliliter here, and what I've already done is I've already filled all these tubes with 4.5 milliliters. So if I put a half a milliliter into 4.5 milliliters, that makes a total of 5. And so I'll be doing a 1 in 10 dilution, or 10-fold dilution. Put my tips on. Take the virus. Draw it up. You have to be very dexterous. Make sure I've got the right one. 0 hour, first dilution. So you probably can't see, but that's just a little bit pinker than the clear liquid. I'm going to do that from tube to tube 2 more times. There's my source. this virus is actually comes from the family called pox viruses, and that probably sounds familiar to you. It's related to the smallpox virus, and of course many of us have been immunized against smallpox when we were small, which means that in general our body is not susceptible to the smallpox virus. But if it does infect GCT cells, that then will be a good thing. So basically that's it. I'll come back later and I will infect the cells and do a reading later to see how some of the plates have done.